Good day, grade 10 learners. Welcome to our mathematics lesson. I am Sikulile Ngube. This lesson is brought to you by the Gauteng Department of Education. Right, what are we going to learn today, grade 10s? We are going to continue with our lesson on functions, how to interpret functions, algebraic functions. So we're going to continue with this lesson. We did the lesson last week. Right, let's see if we can manage to learn something today. Right, so this lesson basically we are going to be focusing on the revision part. We are preparing for what? We are preparing for our end of year examinations, okay? So now we are sort of revising. And then when we're doing our revision lesson later, remember we're going to have a revision lesson specifically for paper 1. We are going to leave out functions because we have covered them, okay? We just look at what? The algebraic algebra and number patterns. Right, today we're going to look at this. We're going to interpret algebraic functions. Refer to the CAPS document, page 24, and then examination guidelines, page 6. Right, the concepts are a bit challenging, so I'll try to be slow. Let's try to move together. If I ask you to do something, do that, and then ask questions. Remember our WhatsApp line 064 748 8913. You cannot learn by just listening. Ask questions. Okay, you're free to do that. Do that. Now we've done the quadratic function, we've done the hyperbolic function, we've done the exponential function. So these are the things that we've done in the previous lessons. Right. So let me just give you the structure of paper 1. It's mainly algebra. We'll cover this mainly when we do our revision lesson, right, next week. And then we have the functions. We're doing functions now. So when under revision lesson, we're not going to do that. It's 30 marks, and then number patterns is 15 marks. All these, they give you 75 marks, okay? Right. And then these are common errors that we usually get, okay, from learners. Domain and range. Remember, learners, domain is in terms of x, which are your input values, which are your independent values. Okay, that's your domain. Domain is in terms of x. Don't lose those marks. Okay, and then the range is in terms of y. Don't lose those marks. Range and domain, you must get those marks. Right, recognizing transformations. Okay, fortunately, grade 10s, we're just doing what? The translation, the Q. Do you remember the effect of Q? Right. If Q is positive, the graph is shifted upwards. If Q is negative, the graph is shifted downwards. Do you remember that? Okay? Do you remember that? Okay. So don't make mistake there. Difference between exponential and quadratic functions. I've seen learners asked to sketch this graph. F of x is equals to x squared. And then someone draws a what? An exponential function. Or given this, f of x is equal to 2 to the power x. And then someone draws a quadratic function, a parabola. So there's this confusion between what? A quadratic function and an exponential function. This is the exponential function. You can see the x is the exponent, okay? And then this is quadratic. You can see there the degree or the exponent there is 2. Okay, so you see that. So take note of that. And then reading solutions from graphs, we're going to do that a lot today. Where is f of x above the x-axis? Where is f of x greater than g of x? Something like that. We should be able to do that. So these are the things that give us problems as what? As learners. Okay, right. Now, before we move any further, I want us to try this baseline activity. Remember, we did something like this in the previous lesson. Okay, so these are free marks. I want us to do all these marks. Remember, grade 10s, right? You get easy questions, and then there will be some challenging questions, but most of the marks are coming from these easy questions. Okay, so I want us to redo this. Now, determine the coordinates of A, B, C, and D, and then determine the coordinates of E and F. Let's start by finding the coordinates of A and B. 2 minutes. Let's find the coordinates of A and B. Let's do that for 2 minutes. Let's try. Welcome back, grade 10s. Did you manage? I'm quite sure that you tried them. Right, let's find the coordinates of A. What did I say in the previous lesson? Ask yourself this question. What is A? Actually, A here is two things. One, it is a turning point. Two, it is a y-intercept. Ask yourself that question. What is this point? So A is the y-intercept. A is the turning point. Remember when we started functions, we said for the function f of x is equals to ax squared plus q. The coordinates of the turning point, let me write TP for turning point. We're what? The coordinates TP for turning point, okay? Turning point where 0, q. Do you remember that? The coordinates of turning point were 0, q. So what is q for A here, for g of x? It is 6. So the coordinates of A are 6. Is 6 there. Sorry, 0, 6, 0, 6. You see that? Because q is 6. Okay? If you are treating it like what? Like a y-intercept, where there's x, put 0. Okay? Don't wait. Now you can see I've substituted here. Just put this in the calculator and see what you're getting. Don't wait for me, okay? Because in the examination you're going to be using what? Calculators. Okay? We have substituted. The question was g of x. Remember, g of x is y. Is equals to x squared plus 6. And then we substituted 0 there. So if you're finding the y-intercept, where there's x, you put 0. Okay, don't forget that. And you are getting what? Y is equal to 6. Meaning that if x is 0, y is 6. So the coordinates of A are 0, 6 there. Okay, it is 0, 0, 6. Okay, right. Now, did you try B? Okay, same concept. Okay, this is our Q. This is our Q. So it means the coordinates of B will be 0, 8. Okay, let's treat this B as the y-intercept. Okay, now what we're doing, our turning point is also what? Our y-intercept. So where there's x, we put 0. Okay, let's put 0 where there's x here. We put 0 here. And then what do we get? You see that? We put 0 here where there's x. What we get? we get y is equal to 8, meaning that the coordinates of B 0, 8. You see that? Okay. Don't lose marks. You're going to get such questions in the exam. You're going to get such. Right. Now, I want us to move on to the next two points, which is C and D. Let's find the coordinates of C and D. Remember to ask yourself this question. What is C? What is D? I'm going to give you 2 minutes. Let's try. Welcome back. Grade 10s. Remember our WhatsApp line 064 748 8913. Remember the WhatsApp line. Send us your questions. Send us your input. Send us your work. Okay? Right, did you manage? What is C? What is D? What are they? Can say the answers there in the classroom. What is C? What is D? These 2 points. These are the x-intercepts of f of x. These are the x-intercepts of what? Of f of x. Okay. So now, what do we do to find the coordinates, the x-coordinates of what? Of the x-intercept. Where there's y, we put x. What am I saying? Oh, say it's confused now. Where there's y, we put 0. Okay. To find the x-intercept, where there's y, you put 0. Because along the x-axis, remember that, along the x-axis, y is equal to 0. That's why we're saying, put 0. Along the x-axis, you have your y coordinate. It is 0. Along the y-axis, you have your x coordinate. It is 0. You're just finding the other. Okay? So now, C and D are on the what? X-axis. So their y coordinates here for C and D are 0. So what is x? So where there's y, we put 0. Okay? Right. Now you see that because the equation is f of x is equals to negative x squared plus 8. Okay? Right. Now, what do we do? We can transpose. Remember that. We can transpose. Right? Negative x squared comes to the left, becomes positive x squared. And then what do we do to get x? This is x squared. You see that? Right. Now, we square root both sides. You square root both sides. What you do on the left, you do on the right. Okay? The square root of x is plus or minus root 8. So it's positive or negative root 8. And then if you're asked to leave it in set form, leave it like this. If it's decimals, 2 decimal places, leave it like that. Okay? Right, so actually here there are 2 answers for x. It is x is equals to root 8, which is positive root 8, or x is equals to negative root 8. Please recognize that. This is 2 things, 2 different things, okay? Right, now we have the coordinates of C and the coordinates of D there is 2 decimal places, the x coordinates in 2 decimal places. Right, say the coordinates, okay? So we have both x and y, we have both x and y. Okay, right, now let's move on to the next part. We want to find the coordinates of E and F. Again, I like giving you 2 minutes. Right, E and F, but now I'm going to give you what? 3 minutes. Let's find the coordinates of E and F. Let's try. 3 minutes. Right, I really hope you managed to do the question patterns. Did you manage? Right, what are the coordinates of E and F? Again, ask yourself these questions. Okay, what is point E? What is point F? Okay, these are points of intersection. This is where the 2 graphs meet. At the points of intersection, the 2 graphs are equal. Okay, some of you may be doing even maybe, I don't know, is accounting or what, or economics, where you have got the 2 lines meeting for cost and what is cost and income. Where they meet means those 2 things are equal. It's called the break-even point, something like that. Okay, so where the 2 graphs are meeting, the 2 graphs are equal. Remember that. So we've got 3 types of points here. can be the x-intercept, or even 4, we talked about the turning point, and the y-intercept, and the points of intersection. Okay, so now at the point of intersection, f of x is equal to g of x. They are equal. Equate the equations, equate the functions. We're solving them simultaneously by equating. Okay, so what is f of x? This is f of x. What is g of x? This is g of x. So you just write that negative x squared plus 8 is equals to x squared plus 6. And then what do you do after that? We can move our things. Remember now in grade 10, okay? But if it's still confusing, you can use the additive what? Inverses, whereby you subtract with the same thing both sides, or you add same thing both sides. Now we're saying we can transpose, right? We move negative x squared to the right becomes positive x squared. So what is x squared plus x squared? There's another confusion there. You find people saying x squared plus x squared, then x to the power 4. No, no, no. We're not multiplying, we're adding like terms. So x squared, 1x squared plus 1x squared is 2x squared. Then we move 8 again, becomes negative 8. And then 6 minus 8 is minus 2. You see that? So that's why we have 2x squared here and negative 2 there. Check that. Okay? Right, now we want to solve for x. What do we do? What do we do? Right, we can divide everything by 2. There are many ways you can do it. Someone can bring the 2 this side and divide by 2. It's still okay. It's still okay. You can even now do your own method and see if we're going to get the same answer. Right, so I divided everything by 2. Divide by 2, divide by 2, divide by 2. Then we get 0 is equal to x squared minus 1. Right, and then now we can do these methods. Difference of 2 squares, because this is actually 1. 1 is a square number. So you can use difference of 2 squares, or you do this and square root both sides. You can get plus or positive or negative 1 for x, or you get your answers like this, which is just the same thing. Okay? Right. Are we done? Are we done, grade 10s? We found our answer. X is equal to 1. And then x is equal to negative 1. Let's look at the question. What does the question say? Determine the coordinates. You see that? It doesn't say the x coordinates. The coordinates, we want the x and y. So what are we supposed to do to get the y coordinates? What are we supposed to do? Remember, you can give the answers there in the classroom. What are we supposed to do to get the y coordinates? What do you think we may have to do? Do you remember solving simultaneous equations? When you get the x values, what do you do to get the other values, the y values? You substitute them into any of the equations. Usually we use the simpler one, okay? But the two equations will give you the same answer. So now that's what we have to do. Now we need to find, because the question says find the coordinates. If it says the x coordinates, then we're just going to end here. But we want the coordinates. So now, where there is 1, where there's x, which one did I use? I used g of x. So where there's x, I put 1. You see that? And then where there's x, I put negative 1. Because you've got these two x values. And then what did I get? Y is equal to 7, and then y is equal to 7. Even this was going to give you the same thing. You can try that and say, negative 1 squared plus 8, you will get 7. Or say negative 1 squared plus 8, you still get 7. So you substitute into any. So now the coordinates of E is negative 1 and 7, and then the coordinates of F 1, 7. You've answered the question. Okay? Right. Now, we're going to continue with our questions. Given f of x is equal to x squared minus 1, and g of x is equal to 5x plus 5, and that A and C are the points of intersection, and F and G, the point of intersection of F and G. Both graphs cut the x-axis at A, and F cuts the x-axis at B. What is the common mistake here? The Cretans look at the diagram, rush to the questions. They don't take time to read. Read the information, look at the diagram, the given diagram, and even check the questions, and then go back and read the information again. It is very, very important. There is time allocated for that in the examination. Don't rush. Okay? Right, let's go to the questions. I want us to do the A, B, C, D. Let's start with A. Find the coordinates of A, B, and C. Right. I want you to pretend you're in the examination. Okay? I want you to find the coordinates of these 3 points. A, B, and C. I'm going to give you 4 minutes. Okay? And then after 4 minutes, I will explain everything. Don't wait for me. Some of you, I know, you will wait there, not doing anything and waiting for me to explain. No. Try. Even if it's hard, try. And then after 4 minutes, I will explain everything once. Let's try that. Well done, grade 10s. Well done. Remember our WhatsApp line 064 748 8913. Remember to send us your questions, you send us your work and your input. Okay? Right. The coordinates of A and B. Point A, point B. I will ask myself this question. What are these points? They are the x-intercepts of f of x. So where there is y, I put 0. You do that. Right, so these are the x-intercept. Where there is y, we put 0. Remember, it's f of x is your y value. Right, it's x squared minus 1. So where there is y, put 0. Okay? Right, and then we solve for x. Like I said, you can use difference of two. What am I doing here? Okay. Right, yes, you can use difference of two squares so that you can solve. Remember that. Or you can square root both sides. Okay, whichever method is faster for you. Right, and then it means 1x is equals to plus 1 or x is equals to negative 1. Okay, x equals to positive 1 or x equals to negative 1. So it means the a value here, the x coordinate of a will be negative 1, the x coordinate of b will be positive 1. Okay, right, now we know because it's on the x-axis, y is equal to 0 on the x-axis. So it means these are the coordinates of a, and then this is the coordinate of b. Okay, right. C. What is C? It's a point of intersection. So actually point A is 2 in 1. It is an x-intercept of f of x. It is also a point of intersection. And now it means when you're solving for A, for the coordinates of A, we must get the same answer we got in the previous calculations. Do you see that? We must get this. Otherwise, if we don't get that, there's something wrong. There's something wrong. Okay, let's see if we're going to get that. C is the point of intersection. We equate our functions. F of x equals to g of x. This is f of x. This is g of x. You see that? Okay, right. And then now, this is f of x. This is g of x. Right. Now, we transpose. I've moved 5x to the left so that it becomes negative 5x. And then I move 5 to the left, it becomes negative 5. And then negative 5, negative 1 is negative 6. Negative 5 minus 1 is negative 6 is equal to 0. This is called the standard form. Very important. Actually, you're getting a mark for this. Okay? For equating the functions and standard form. You cannot solve a quadratic equation if it's not in standard form. You have to. Whether you're using, later in grade 11 you're going to be using the formula, whether you're factorizing or using the formula or even completing the square, you have to make sure that the equation is in standard form first. The zero principle. 0 on one side, the algebraic skeleton on the other side. Do that, please. Okay? Every time. Standard form. You get the mark for that. Right, now, what do? We have to factorize. How do we factorize? We have different methods of factorization. Now you can be trying your method. I'm going to show you one method. Okay? So what we do, there's a 1 here, an invisible 1. So we say 1 times negative 6, which is negative 6. Okay? Right. These signs, they guide me. These signs, they guide me. This sign here, the first one here, this one, negative means that the other factor is negative and the other factor is positive because we're multiplying the factors. If you're multiplying something and getting a negative, it means the other one is negative, the other one is positive. 1. So it means the other one is negative and then the other one is positive. That's what I get from this sign here. And then this sign, the negative, it means the bigger factor is negative because you'll have a smaller factor and a bigger factor. If it is negative, the bigger factor is negative. If it is positive, the bigger factor is positive. So this is negative. It means that the bigger factor is going to be negative. Then I look for the factors. The factors of 6. There's 1. What do I multiply 1 with to get 6? I multiply 1 with 6. 1 times 6 is 6. And then there's 2. What do I multiply 2 with to get 6? I get 3. 2 times 3 is 6. So these are the factors of what? Of 6. Right. And then 1 goes with 6. You see that? Okay? And then 2 goes with 3. Now, there are 2 pairs here. 1 and 6 and 2 and 3. Which combination can give us negative 5? Remember, the other one must be negative, the other one must be positive, and the bigger one must be negative. So which combination? Is it 2 and negative 3? What is negative 3 plus 2? That's negative 1. It's out. And then negative 6 and 1? That's what we want. Negative 6 and 1. Okay? And then if the coefficient of x squared here is 1, you don't need to stress. Don't stress. Just write your factors. X negative 6, which is one of the factors of 3 there, and then x plus 1. Done. Okay? I've written on top of the animation now. I got too excited, but it's fine. Right, so x minus 6, x plus 1. Now, we have the factors here. It's either x negative 6 is equal to 0 or x plus 1 is equal to 0. Do you see that? Okay? And then, therefore, x is equal to 6 or x is equal to negative 1. These are what? The coordinates of what? Of C. You see that? So, this one is going to be the one for A. We got negative 1. Okay? Right. And then C, the x value, the x coordinate is 6. What is the y coordinate of C? What do we do? Where there's x, we put 6. Let's use the linear equation because it's the simpler one. So we just substitute 6 there. We'll see. And then what do we get? We're getting 35. So it means if x is 6, y is 35. And then this one just confirms that our calculation for A in the previous one was correct. So this C is 635. Done. You see that? Okay. So that's what I gave you the 4 minutes for. That's what you're supposed to do. Send us your questions. 064 748 8913. Okay. I haven't seen any question. I haven't seen any work. Remember, we have to interact. Right. Now, interpreting graphs. Interpreting graphs. Okay? You'll get one. Okay? Not a lot about this. So you need to understand, right? Okay? When I'm saying f of x greater than 0, what is the meaning of this? We did this when we're looking at what the graphs, functions, domain, and range. When I'm saying a greater than 0 means positive. So f of x greater than 0 means where is f of x positive? When I'm saying f of x less than 0, what is the meaning of that? It means where is f of x negative? F of x is equal to 0 along the dotted line. You see? This is f of x equals to 0. Remember, f of x is y. Let me write y before that. Y equals to f of x equals to 0. So along the x-axis, f of x equals to 0. What about above the x-axis? Above the x-axis, f of x is greater than 0. So when I'm saying where is f of x greater than 0, I'm saying where is f of x above the x-axis? Less than 0. F of x less than 0 means where is f of x below the x-axis? You understand that? Now let's answer the question. So we're going to divide our graph into regions and then investigate each region. Right, we're going to have our first line here. Let's look at the left of this line. This line is what? Is x is equal to negative 1. Coming from this, x is equal to negative 1. So on the left of this line, what can we say? X is less than negative 1. Remember the number line. If you're going to the left, the numbers are lesser. If you're going to the right, the numbers are bigger. Okay? Right. Let's investigate each graph now. There are 2 of them. Right. Okay. We have f of x. remember we have our dotted line here. So f of x on the left of the red dotted line is from here going up. Where is it? It is above the x-axis. So f of x is greater than 0. This. Okay, so here f of x is greater than 0. Okay. What about between these two lines? Between these two lines. This one is 1 because remember b, the coordinates of b is 1 here. The x coordinate of b is 1. Okay. Between the interval. How do we write the interval? X at the center less than -1, 1. This means x is between -1 and 1. That's the interval. Where is f of x? Where is f of x between these two dotted lines? Right, this is f of x here. You see that? Here, f of x is less than 0 because it is below the x-axis. Okay? And then we have again the last part, which is from here. Now I've written a lot of things. Is x greater than 1 to the right of this line, the dotted line. X greater than 1. Okay, where is f of x? If you check, okay, this is your f of x. It is above the x-axis. Again here, f of x is greater than 0. It is above the x-axis. So where is f of x above the x-axis greater than 0? It is here and there. Okay, and then you just write your solution like that. It is x less than -1 or x greater than 1. Okay, right, don't forget that. Now let's go to the next one. Okay, for which values of x is f of x less than or equals to g of x? Okay, now you are comparing the two graphs. It's no longer, the previous one was f of x greater than 0. Now we are comparing f of x and g of x, the two functions. Now these changes happen at the points of intersection. Okay, so draw your line on the points of intersection. This is x is equal to 1 there, and then there's another line which is x is equal to 6. Now then we investigate each region and see where is f of x below g of x. Where is f of x below g of x? Okay, right, now let me just cancel this. I don't want to use an eraser because it may confuse me. Right, now where is f of x below g of x? Okay, right, let's look at this region here going this way. This is x less than, they said less than or equals to. Okay, so let's take note of that. I'll also say less than or equals to -1. Okay, let's look at the left of this line. Where is f of x? This is f of x. Where is g of x? This is g of x. Okay, this is g of x. Okay. On my pen, where is it? Okay, and then this is f of x. Okay, so now which graph is above the other here? F of x is actually greater than g of x. So this region is out because f of x is greater than g of x. Now let's look at between -1 and 6. This region. -1 and 6. Okay, now which graph is above the other? Okay, let's check that. Right, this is g of x. Okay, and then where is the other one? Let me use another color. This is f of x. Okay, now which graph is above the other here? g of x is greater than f of x. Between -1 and 6, g of x is above f of x. So we're saying this is the region we want. Okay, because in this case, f of x is less than g of x. Okay, right, the last part. Okay, the last part, where is f of x? This is f of x. Right, where is g of x? This is g of x. If you check here, when going to the right, when x is greater than or equals to 6. Now, you see, g of x is now above. F of x, the green graph, f of x is above g of x. So this one is out because f of x is greater than g of x. You see that? So what do we want? We want this region here. Okay, that's our solution. I really hope you managed to get something from this. I'm trying to take time so that we can understand. Okay, let's move on to the next one. Let's move on to the next one. Right, for which values of x is f of x times the dot means times g of x is greater than 0. Okay, right, it's another concept that they like. Sometimes maybe division. And remember this, right, positive times positive will give you positive. So now, if the two functions are giving us greater than 0, it means it's either both of them are positive or both of them are negative. Times negative equals positive. Right, you see that? So it's either both of them are positive or both of them are negative. If it said less than 0, then the other one must be positive, the other one must be negative. Remember, less than 0 means negative. Greater than 0 means positive. So the concept I'm explaining here is the same thing even with the quotient. This is the product. The quotient is division. When you get something like this also, so use the same concept. You may not have time to get such an example, but use the same concept. Okay? Right. So now greater than 0 means positive. It's either the two graphs are positive or the two graphs are negative. Let's check our regions. Let's start with this side. Let's start with this side. X less than -1. Where is what is f of x? It is above the x-axis, so it is positive. And then what about g of x? G of x is where? It is below the x-axis, so it is negative. So here, when x is less than -1, if we multiply f of x times g of x, we'll get a negative answer. We don't want that because we want greater than 0. We want greater than 0. So this is out. Let's check between -1 and 1. -1 and 1. Right. Now, let's start with g of x. Let me use red for g of x from here up to there. Okay, g of x is positive because it is above the x-axis. And then f of x is negative because it is below the x-axis. So between -1 and 1, g of x is positive, f of x is negative. And then, now if we multiply these two, we'll get negative because positive times negative is negative. So this is also out. And then the last region is x greater than 1. Okay, let's investigate our graphs. Okay, right, this is f of x. It is positive because it is above the x-axis. It is positive because it is above the x-axis. And then we come to g of x. It is also positive because it is above the x-axis. So when x is greater than 1, both functions are positive. If you say positive times positive, we get positive, which is greater than 0. This is what we want. Then our solution is when x is greater than 1. Okay? Right. Now, I want us to take a short break, just 1 minute. Okay? I want us to won't take out the screen. We won't take out the screen. We'll just leave the screen in front of you for 1 minute. If you want to discuss, you want to say something about it, you say it. Okay, 1 minute. Okay, let's try that. To understand this, if you've managed to understand, that's good. Please, if you did not understand, continue consulting. We're waiting for your questions. 064 748 8913. Okay, let's move on to the next question. The sketch below shows f and g, the graphs of f of x, which is a hyperbolic, 1 over x minus 1, and then g of x is equals to a, x plus q respectively. The points A and B lie on the graph of G. We can see the points A and B there. Okay, the two graphs intersect at point C, we can see that, and point D, we can see that. Line BE is drawn parallel to the y-axis with E on F. Okay, right, we may not use that because of time, but let's just see what we can do. Right, show that A is equal to Q, what am I saying? A is equal to 2 and Q is equal to negative 2. Right, let's start with question 5.1. Now, because of time, I'm going to explain everything. I'm not going to give you time to do an activity, okay? Right, now, remember this great tense. How do we write the equation of a straight line? Okay, because we have point A and point B there. Remember, we can use these points on the straight line. Remember, we can use this, okay? Then the equation of a straight line, remember we said is f of x is equal to mx plus c, or you can say y is equal to mx plus c, still fine. And then you can say f of x is equal to ax plus q. What is m? This m here, or what is a? Okay, m is the gradient, a is the gradient. What is c? The y-coordinate, of the y-intercept, that's c. Q, the y-coordinate of the y-intercept, that's your q. So m and a is one thing, c and q is one thing. Right, now what do we do? Let's start finding. A is the gradient. We know the gradient formula. Right, mathematics is mathematics, okay? We're doing functions here. Some of you saying, well, gradient is, we find it in analytical geometry or coordinate geometry. Find the gradient. You find it in functions. Find the gradient. So you can do like this, okay? 4, start with y, 4 minus negative 4. Do you see that? 4 minus negative 4 over 3 minus negative 1. You see that? Using the gradient formula. And then 8 of the gradient is 2. See? A is 2. Or even if you had said, negative 4 minus 4, and then negative 1 minus 3, you're still going to get the same answer. Okay? You see that? So A is equals to 2. So where there's A, we can actually put 2 here. Now, how do we find C? Do you remember that? How do we find C? We substitute any coordinate on the graph. So we can substitute this point, or we can substitute this point. Let's substitute any of those. I use this point. Where there's y, I put 4. Where there's x, I put 3. I use this point here, this one. Okay? See that y4, x3. Then we solve for q. Q is equals to negative 2. You see that? We have done the first part. Okay? 5.2, determine the values of x for which f of x is equals to g of x. We have talked about this is a point of intersection, so equate the functions. This is your f of x, this is your g of x, and then we solve for x. Okay, right, now I brought, what did I do? I brought -1 this side, becomes +1, and then -2 plus 1 is -1, and then we multiply everything times x by x, x times x times x, then you get this. Okay, right, now we have to do the long method for what? For factorizing this. Okay, using your own method, we must factorize and get these two factors. Okay, let me try to quickly do that. Right, 2 times -1 is -2x squared. Right, sometimes you don't even write this, you just write -2. The factors of -2 that will give us -1 is -2 and +1. So we say 2x squared minus 2x plus 1x, you can say plus x, minus 1 is equal to 0. Factor out 2x, then becomes x minus 1. Factor out 1, and then you get x minus 1. Okay, right, you have got a common bracket here, which is x minus 1. And then you factor out x minus 1, you'll get x minus 1 and 2x plus 1, like that. Okay, and then you can solve for your x, which is -1/2 and 1. See that? So these are the coordinates of what? Of C. You see that? And D, the x coordinate. Okay, let me go back a bit. They said x. Okay, so now that is enough. Okay, the x values is enough. For which values of x is g of x greater than f of x? Where is g of x above? Above what? Above f of x. Now, if we check, this is our answer here. Where did I get this answer? Right. Now, here we said, oh, sorry, the parabola is what? Is f of x. So here f of x is above g of x. So it's out. We want where g of x is what? Is greater than f of x, which is here. Right, this is g. Let me write g here, straight line, and then f here. But remember, there's an asymptote here. X is equal to 0. And we can never include the asymptote. So what is this interval here? This one. Okay. Right, this one is -2, and then here is 0. So x is between 0 and -2. It's between -1/2 and 0. That's this point, from there to there. I'm trying to rush here. That from there to there is -1/2 and 0. Now we cannot include the asymptote. So that's why this one, the 0 is not included. So it's from -half included to 0 not included because of the asymptote. And then here g is above f. That's what we want here. Greater than or equals to. So now we cannot say greater than, less than or equals to 0 here, because this is an asymptote, not included. Okay? Right, and then please do ask questions. Say or meme in the classroom also, they can assist. Also send us your WhatsApp, will assist. Okay? Right, and then if you check this side, this one f is above g, so it's out. And then this side, g is above f. We can see that from here going, this one is x greater than or equals to 1. You see that? That's why we have that solution there. Okay? Right. Write down an equation of h of x of h if h of x is equal to f of x plus 3. 1 mark. Check the mark allocation there. It means you don't have to do a lot of things. Okay? So actually, where there's f of x, just put f of x. Okay? Remember what f of x is. This is the f of x. We have replaced f of x with 1/x minus 1. Remember, this is our f of x. Okay? So where there's f of x, just put f of x. We've substituted. And then what do you do? And then simplify that. Simplify that. What do you get? You get h of x equals to 1/x plus 2. Done. Okay? Right. It was a long lesson. Try to be slow a bit when you started. Towards the end, I tried to move fast so that we cover all the concepts, but I really hope that you managed to learn something. Okay? Right. We will not have time to copy the question, but let me show you the slide here. Remember, you can pause the video a bit and then you copy the question there on your own. Maybe you need about 2 minutes while you're waiting for the next lesson. And then also here, okay, you can go back a bit and just pause the video and then you copy what? You copy the lesson and then you'll be done. I think you need just 2 extra minutes there. Okay, but let's move to the summary. There's nothing much. What did we say? At the x-intercept, y is equal to 0. At the y-intercept, x is equal to 0. And at the point of intersection, the two functions are equal. Equate them. Right. I really hope you learned something, cretins. We are going to meet in our next lesson where we're going to deal with Euclidean geometry. Okay, remember that paper 2, there's Euclidean geometry. We're going to bring a lot of writers that we're going to deal with, and we're going to learn a lot, and then we'll be prepared for our end of year examinations. Remember to sanitize, to social distance, and to wear your mask. And please do press complete once you're done. Right, it's my pleasure. We enjoy working with you, and let's continue doing our best. Right, let's meet in our next lesson. Goodbye.